Let's look at substitution. Substitution is a method to find points of intersections between two linear lines. Sounds like a lot of mumbo jumbo what I said, but I'll kind of explain it with a quick graph. So here's our x-axis and our y-axis, right? So we have y like a yo-yo up and down, and our x-axis. And this equation here technically represents a line. We're used to looking at lines when they're written as y equals mx plus b. This one's just been rearranged. This line falls somewhere on the graph. We'll just pretend it does that. And the second one, excuse me, is very similar. It's a line again, and it falls somewhere on the graph, and maybe it does something like this. Substitution is a way that we can algebraically, so that means by using our values, find out where the two lines cross each other, right? And linear equations will either have one solution, no solutions, and no solutions would be if they're parallel lines, they'll never cross, or infinite solutions. And an infinite solution means they're the exact same equation drawn on top of each other. I'll quickly tell you right now that's not the case. So, and they're not parallel either, so that means we're going to have one solution. They can only cross once, okay? That's just a general overview. So the point of substitution is to isolate for a variable and then substitute everything that's equal to into another variable. Again, sounds funny, but which equation do you want to start with? Because you can start with either. It doesn't technically make a difference.
Number one.
Number one. Okay, and then which variable do you want to start with? We can technically isolate for y, or we can isolate for x. X? Okay, so we'll isolate for x. So we'll keep this as this is our goal, is to get x by itself. Now, there are a couple strategies with substitution, and if you kind of looked ahead and if you knew a bit, it'll actually be easier if we isolate for x when we go to actually substitute in. Okay, that's fine. We'll work from there. Actually, to be all honest, I'm going to substitute y just because it's the harder one, and I want us to go through a harder example, so I shouldn't have asked. Okay, let's substitute for y instead. So in other words, what that means is equation 1, we'll do equation 1 in red, or maybe green. We'll isolate for y. We want y by itself. So the very first step is to take 2x and move it to the other side. So we'll be left with 3y is equal to 4, subtract 2x. So 2x came to the other side, it becomes a negative value. Okay. We still don't have y by itself. In order to have y by itself, we need to divide both sides of the equation by 3. So one of the ways you can think of this is we divide the left side, and then whatever we divide on the right side, we have to do to every single term. So we divide all the terms by 3. On the left side, ooh, that's better. On the left side, 3 divided by 3 just makes a 1 value. It's usually known as canceling out, but it technically makes a 1. So we'll say they cancel out, and you get y is equal to 4 over 3 minus, and you can write it as 2x over 3, or you can kind of write it like 2 over 3 times x. Both are the exact same thing. But what we did here was our goal. Our goal was to isolate for y. So we know that y is equal to this, 4 over 3 minus 2 over 3x. Kind of a weird thing to be equal to. But what we can do now is we can take this and plug it in for the y in the other equation. That was the whole reason we isolated in the first place, is so that we can replace the new y with what we have over here. So when we go to replace the new y, we go into equation 2. Equation 2 reads negative 5 times whatever was in the brackets. So whatever was in the brackets was 4 over 3 minus 2 over 3x. And this is a more difficult question again because we got fractions already. And sometimes they'll set up questions so it's a lot nicer to work with. Outside of that y, we have positive x is equal to negative 9. Okay. So all we did in this step here was replace the y value with what we discovered y was equal to. So we replaced y with what we discovered y was equal to in the other equation. Now, there's only one variable left, x. So because there's one variable, we can isolate. We're going to distribute and simplify and get x by itself. The same idea before. Oh my gosh. Okay, in order to distribute, we take the negative 5 and we have to multiply it by both terms. So we have to remember how to multiply by fractions. Okay, negative 5, I can turn it into a fraction. So it becomes 5 over 1. Okay, and when you multiply fractions, you do the top by the top and the bottom by the bottom. Luckily, 1 times anything will leave the 3's the same. It won't change anything, so we really only have to focus on the 5's. Okay, so negative 5 times 4, and negative 5 times, you can think of it like negative 2. So we distribute, and we get negative 5 times 4 is negative 20, and 1 times 3 is 3. Negative 5 times, and think of this like the negatives on top, negative 5 times negative 2 is plus, so 5 times 2 is 10, and 1 times 3 is 3, and the x still stays. Because we distributed, the brackets disappear, and we have plus x equals negative 9. Again, this is a harder question. There's a lot of fractions involved. So we do have like terms. Our like terms are our two constants. We have negative 20 over 3 and 9. Those are technically constants. There's no variables attached to them. And our other like terms are positive 10 over 3x plus x. They're both x values. So we can put them together. Okay. What I'll do is I'll put everything that's as a variable on the left side, and we'll move the other stuff to the right. So I'm going to move negative 20 over 3 to the right. So that'll leave us with 10 over 3x plus x equals negative 9. When this is, because this is a negative 20 over 3, what does it become on the other side?
Positive 20 over 3.
Yeah, positive 20 over 3. Okay. So, great. We got variables on the left, constants on the right. I need a common denominator. What number is technically in front of this x?
1.
Yeah. And we can think of it like 1 over 1, right? In order to add the coefficients together, we have to add a common denominator. So I got to make sure it's 3. So whatever I do at the bottom, got to do the top. And then the same idea over here. This is technically 1. So whatever I do at the bottom, I got to do the top. Doing a whole bunch of fraction rules at the same time as we do this, okay? Okay, so 10 over 3, x. This becomes plus 3 over 3, x, is equal to negative 9 times 3 is negative 27 over 3. And then plus 20 over 3. So a ton of fractions. The denominator stays the same. 10 plus 3 is 13. So we get 13 over 3, x, is equal to negative 27 plus 20 is negative 7 over 3. Okay. The last thing we can do, to get rid of all of this, we can cross multiply if we want. Okay. So think of this like it's 13x over 3. You can think of like everything on top. So we would cross with this 3, and then cross with this 3. So 13 times 3, that's going to be 39. I really chose a hard one to work with. 39x. And then 3 times negative 7 is negative 21. And then how do we get x by itself? Divide. So we bring it over the other side. It becomes negative 21 over 39. What does that mean to us? It's a fraction. We figure it out what it is as a decimal. We get negative 21 divide 39, negative 0.53, okay? Here's the kicker. That is actually not the entire answer. That's only part of the coordinate. That's the x value. The x value is negative 21 over 39, or negative 0.538, roughly. In all coordinates, that's only our x value. I wrote it as a fraction of decimal. I still have to find a y value. So, and I'll do that very quickly. I'll talk about how to do it quickly, and I'll show us on decimals how this gets us to our answer. Or what we need to do now, here we go, to yellow, is what this means is x is equal to this value. So, we go to the first two equations, and we repeat, just it's a little easier this time. I can put that number in for x here, or I can put it in for x here. It doesn't make a difference. And then we solve again. Okay, that'll be a long process. I can kind of let us do it. I want to show you on decimals. If we type these two equations in, we should get that as our answer. So here we go. 2x plus 3y equals 4 is the first one. 2x plus 3y. And the second one was negative 5y plus x, negative 9. Negative 5y plus x equals negative 9. Is that right? Yeah. And remember the x value. Keep going back and forth. Sorry. Should be negative 0.538. That should be the x value. And if we go and look, negative 0.538. And when they plugged that number into the equation, they discovered that the y value was 1.692. So you just bring that back in. That's how you go about solving that. Again, this is quite a difficult substitution question. Probably the hardest one you would do, or the hardest type you do in grade 10.